But without further ado, I think we should get started here with this wonderful evening of DorkBot activities. We have some great stuff lined up for you. We have a presentation coming up in just a minute here that I'll introduce momentarily. In between that, we will have what is called an open dork session. That is when you have 5 minutes to come up and talk about anything vaguely DorkBot related, some fun tech project you're working on, something you want to show off, anything crazy cool like that. We'll have that in the middle all going on, and then we have another wonderful presentation after that. But up first, we have Mr. Glenn Phillips. He's going to talk about all sorts of amazing things with self-balancing robots. So without further ado, Mr. Glenn Phillips.
That's how it works.
We can go up the stairs.
Well, put that there. Did everyone here come see the Church of Robotronics? 'Cause I'm not with those guys. I'm doing self-balancing robots here. Thank you. There we go. Grassy.
Don't try this at home.
Can everyone hear me? Hi, my name's Glenn Phillips. I come from Hood River. I built several self-balancing devices, small and large. The main ones that I like to show off are the two-wheeled one that I just took out here and my one-wheel one. This one I love. It's fun to let people ride, it's hard to ride, and lots of people fall on it. I was just going to talk to you guys for 10 or 15 minutes here about self-balancing robots and what's involved with self-balancing. When I first saw the Segway come out, people said, well, hey, look at the Segway, it's amazing. It uses a gyro and it can balance itself. So I pictured a big mechanical gyroscope inside this thing spinning, and that's what holds it up. Down the road, I started looking at some websites and discovered that no, the thing knows which way up is by the use of a gyroscope and accelerometer. So I'm going to talk to you guys today just a little bit about how self-balancing vehicles work. The unicycle, I think, is the simplest because it has no steering. I used all existing parts from old scooters. It was easy to build, and then I could just concentrate on the electronics. So the components that we're looking at here, we've just got a couple of drill batteries in it. This is the back end from a $75 broken electric scooter. I got that on Craigslist. I just took my 12-volt battery, hooked it up to the motor, it spun. I gave the guy 75 bucks and I took it home. I cut the end off it, so the drivetrain, everything is intact. I did put a shroud on the chain after I caught my pants in it. The one thing, you know, I thought with self-balancers, everybody on the internet talked about you really need a very stiff drivetrain so you can balance, and they said a chain wouldn't work. This one has a chain. I tightened it. The chain is really tight, so that's really, it was fine. First, I was going to just kind of talk about the people that were the inspiration for me to make this. Dean Kamen, he's the inventor of the Segway. Whatever people say about Segways, it's kind of true. They're very kooky, but the technology is amazing. And everyone says, oh, you know, Phillips, why'd you spend so much time on something that's not that cool? I learned a ton putting this thing together. So let's just talk a little bit about maybe a couple of the other people here too. Trevor Blackwell, the next guy down on that list, he's kind of the granddaddy of homemade segways on the internet. He made one probably 8 years ago, before people were really using Arduinos a lot. He did his own programming. I took one look at Trevor's code though. I could not make heads or tails of it. I have no programming background, no programming experience, but Trevor had an amazing list of the parts. Some of the parts that I'm going to show you guys today, it's directly referenced from him. Next guy down here, Kerry Wong. He's a wizard of electronics, and he documents everything. He made a self-balancer with just a broken toy truck, and he put the electronics on that. His design was very simple, but his explanations are excellent. There's a company called Starlino. They make a really nice serial graph for Arduino, and it's free. You can download this serial graph program. I hooked up my accelerometers and my gyroscopes, and I could see exactly how they were functioning with these Starlino serial graphs. And of course the Arduino, okay? So if we take a look at the insides here, we can take a look, change screens here. That was the scooter. So here's a look at the insides, and on the top right there, you'll see the motor controller. So the main components that we have here, lower left is the Arduino. Just to the right of the Arduino and above that Energizer battery, it's hard to tell, but on a puck, I have mounted the accelerometer and the gyroscope. Above the accelerometer and gyroscope, you'll see 3 knobs, and that's the PID control system. So the general gist of this, you've got the brains, which is the Arduino, the accelerometer and gyroscope, and then it drives the motor controller. So the Arduino is going to put out a PWM signal, pulse width modulation. It's basically taking a 36-volt signal, turning it off and on very quickly, and so it looks like it's 10 volts or 5 volts or 15 volts or 36 volts, depending on how fast it's turning that signal off and on. Most of these computer-controlled motors are using PWM, and if you look, when I ride this around, you might hear a high-pitched noise. That's actually an audible frequency. If you bought a Segway, they make their PWM frequency much higher, so it's not audible to the human ear. This one, you'll hear that as you ride it around, and that's actually the electricity being turned off and on very quick. So first part of the system here is the gyroscope and the accelerometer. If we could just take a quick look at how these things work. The accelerometer, everybody's got one in their phone, everybody knows what they are. The easiest way to picture how an accelerometer works is picture a ball inside a square. If there is no gravity like this illustration here, and the ball was just floating inside the square, there's no weight on anything. So every wall of that cube notices 0 G's. And that's what's measured with an accelerometer, is the force of gravity. Now, if we put a force to that, still in 0 gravity, now the ball is going to hit that wall. And that wall is going to sense some portion of the force of gravity against that wall. Now, since we are in a 1G condition right here, sitting on the planet Earth, that ball is going to sit on the bottom of the cube. So the bottom senses 1G. If we start to tip our accelerometer, the ball, part of the weight may be on 2 walls or 3 walls, and now your accelerometer knows that that the axis has changed, okay? So that's how an accelerometer works. The thing that is tough about accelerometers now, if you had a system that's moving slowly or almost not at all, that's great. But once you have something that's bouncing around and moving, all of a sudden this ball is inside here hitting every wall, and you're essentially getting a lot of noise, okay? So that's where a gyroscope comes in. A gyroscope measures rotation, only rotation. And so what a gyroscope knows is, I just tipped 3 degrees this way, I just tipped 5 degrees this way, I just tipped 10 degrees this way, I just tipped. So that's what a gyroscope knows. Now, basically in these instances, the only thing I'm using the accelerometer for is to be a reference every once in a while. Mostly what it's balancing itself with is the gyroscope. And it looks back to the accelerometer every once in a while and it says, where am I? The accelerometer says, gravity is this way, up is this way, okay? So that's how the gyroscope and the accelerometer work together. If you look, many of these, and in fact the one that I have in here, it was $35. It's from SparkFun. It contains a gyroscope and accelerometer in one. Some of them have 6 degrees of freedom, some of them have 9 degrees of freedom. So basically, left, right, up, down, forward, backward. Those are your degrees that it knows. In the case of a self-balancer, I really don't care about my side to side. In a Segway, you don't really have side to side tipping with a 2-wheel vehicle. And even on the unicycle, you're responsible for the side to side. So all I'm interested in my formula here is, am I tipping over forward? Am I tipping over backwards? Okay? And that's called your error. So this thing, basically with a Segway or any self-balancer, all it wants to be is standing vertical. If it decides that it's starting to tip forward, this is the classic inverted pendulum. So it says I'm tipping forward, I want to fix that. So I take my wheel and I accelerate forward, and that brings the wheel back under my gyroscope. The gyroscope is pointing straight up and down again, and that's what it wants. The more its error increases, the more the drive increases so that it tips itself back to 0 again. And again, there are ones, I don't know, you may have seen on the internet, it actually sits on a ball, and the ball now has, you can do this side to side and back and forth. It's a very interesting concept, and this one, you can go in any direction and it will balance itself. Great for use in chairs, office chairs, and things of that nature. Okay, so
That would be a project for next time that you want with the ball?
I've thought about it. I've got another project that's in the works here, but the gyroscope and accelerometer, that's the information. It goes into the Arduino. You use Pythagorean's theorem, the a squared and b squared, you know, equals c squared. That is your distance that you're off from being straight up and down, okay? So there's our accelerometer and there's our gyroscope. The motor driver, this little device right here, it comes from a company called Robot Power. They're $120 if you put them together yourself. I think I paid $200 for the one that was pre-done. It can handle 100 amps of power. I've already put 100 amps through it, and it's still working. They're pretty impressive. This picture here, the capacitors in it had been hit with my drill, and I just unsoldered them and put two new capacitors in, and the things worked fine. Once you get your information from the gyroscope and the accelerometer, it's processed with the Arduino, then it's turned into a signal from the Arduino, and that signal is magnified with this motor controller. And that's really all there is to it. Some of the things that are the most daunting is battery power and motor power. I believe the software that I have running on this is pretty darn efficient, but this thing, if it is not on a perfectly level, perfectly flat surface, it's gone. If you hit a bump, it's over. If you're going uphill or downhill, forget it. This one, much more powerful motor, much more torquey. The two motors on this are both 36 volts, and they have a 29-to-1 gear reduction in them, which makes for very smooth and stable action. Now, once the motor gets its information, you want to have some controls, because your batteries may run down, you may have a more powerful motor, you may have a less powerful motor, and that's where a PID control system comes in, a proportional, integral, and derivative. So the information that comes out of the gyroscope and accelerometer, processed by the Arduino, and before it gets sent to the motor, the PID gets a hold of it. And the easiest explanation for a PID control system is like a shock absorber. So the P is your overall gain of the whole system. It's like, is this a shock absorber for a semi-truck, or is it a shock absorber for a bicycle? Okay? And in a PID system, we have a set point. Where do I want to be? I want to be right here. And as soon as my system starts coming up to here, I want it to stop, but I don't want it to stop too bad. That's where your integral comes in. It's like the spring. And the spring, without dampening, would go back and forth, back and forth, back and forth. That's where the D comes in, the derivative. And so you take your derivative, and all of a sudden you say, whoa, I'm coming back up to my set point now. I don't want to pass it. I'm going to slow down. I'm going to stop. I'm going to let off on the power. Here we are back at our balance point again. Oh, we went by our balance point. I got to come back again. And so we're always using that integral and the derivative. And on this one, I actually have to use the proportional, integral, and derivative every single time by hand. And that's right here. The three knobs that are right there on this. So when you put a little too much of the proportional gain, you start cranking up its proportional gain, the thing will just start balancing really sluggish, balancing sluggish. And as you get to too much, it'll all of a sudden start to vibrate uncontrollably. As soon as it vibrates uncontrollably, you just back it off a little bit, boom, that's fine. Then you hit that I and the integral. What you feel in this, when you get on this with just the proportional set, it feels very soft and squishy, and you can almost not even balance on it. When you start cranking up that integral, all of a sudden it gets stiffer and stiffer and stiffer. Then you give it a little bit of the derivative, and it makes it a little bit more mellow. And so that's really all that's involved. The best part I found about this was the people that were available to help and online. It's absolutely amazing who's out there and to walk you through this. I had almost no programming experience. I shouldn't say almost, I had no programming experience whatsoever. I sat down, I copied the Arduino formats, I copied the Arduino, I copied people's programs on there, I started running them. I got certain parts to work, certain parts didn't work. As people helped me out, the thing started working. And as soon as I got the unicycle to work, I found a $350 wheelchair on Craigslist, and then I made the 2-wheel version. So that's really the long and the short of it. Whoops. Yeah, it's off. That's really about the whole thing. So I appreciate it, and if anybody wants to ride the unicycle after, this is we got a helmet. We got a helmet and some ski poles. I do use ski poles normally with this one because it's a really tough one to balance. And I've let people that do have unicycle experience ride it, and they are the worst ones on it. One of my buddies, I sat him in the garage. He goes, I know how to ride a unicycle. I said, that's fine. He sat on it, and he went right out the garage backwards, right into my car. And he was trying to balance it. He was trying to balance it like a unicycle. And even this one is the same. You need to rely on it, step on it, and it balances itself. And so that's it. And if anybody has any questions or anything about it, I'd be open to any questions. Yeah.
I was wondering what the top speed is for both.
Okay. The top speed, this one, I got going 11 miles an hour, and there's 2 ways that you could actually get it going faster. If I put bigger wheels on it, it would go faster, and if you up the voltage, it will go faster. You could get it up to scary speeds, but as your speeds increase, now your motor may not have enough torque to balance you anymore. And I have no safety mechanisms built in, so it'll go down if it doesn't have anything left. Uh-huh. Well, and that's funny. Other people have, someone asked about auto-tuning algorithms for PID. When I first started doing my PID controls, I just did it with the computer. So I'd go in and I'd change all my PID levels, and then I'd go and I'd try it again. And one of my buddies is actually, he works for a drone company in Hood River in Situ. And I said, hey, Arm, can you help me with this thing? And he goes, dude, I'm not even going to touch that until you put knobs on it. So I put 3 knobs, and the knobs corresponded to what I was putting on the computer. And when I put the knobs on it, then all of a sudden, tuning was easy. And PID tuning, as far as these, you tune the P until it vibrates, crank the I as much as you can, and just a little tiny bit of the D, and that always works. You in the back there? That's what PID is for. If you put someone on it that was heavier, they can crank it up a little bit more. So, and that's, if the battery starts to run down, then you would adjust the PID settings as those things change. That's why, if you didn't have a PID, it would be much more static. It would not work as well in different situations. Yeah.
Is the PID controller a separate piece of hardware, or is it just software running on the Arduino?
It's just software that runs on the Arduino, and if anybody wants to look at the code, it's pretty straightforward. It's just one formula. Yeah.
There's a guy that used to be down in Southeast Portland, Weston, who's control. He's got a PDF on his website, or did have. I downloaded it back in, which goes through some manual PID algorithms and then a couple of auto-tuning ones. He was the guy I was studying, looking at the PID stuff.
Right. A lot of systems, you know, especially industrial control systems, you're controlling equipment that's a lot more expensive. And so they will run computer simulations and say, you know, what happens, because you don't just want to crank up your gain until your machine starts going crazy. My machine, I can do that. A big, expensive industrial machine, you want to know what your settings should be before you start really cranking on the knobs. That's what I've seen with larger industrial control systems. But it's the same technology, and to make a PID control system yourself and to start to use it, it becomes a lot more simple. And certain people that did work in industrial controls, they just can't believe that we would put 3 knobs on it and just start cranking it up until it shakes. Yeah, and that's what other people in the self-balancing world, that's been the norm, is to just crank them up until you got as much as you can. Now, on the Segway, this motor is probably a 1/4 horsepower, where a Segway has a 2 horsepower motor on each wheel and a very powerful lithium-ion battery. That's the holy grail of self-balancing. If you really want a smooth self-balancer that can go up things, down things, hit bumps, go over rough ground, you need a very strong motor. Then your PID can be mellowed out. Mine is just at the very max it can possibly be. It's got nothing left. Yeah.
Do you find that you have enough resolution with the PWM and all the controls that the AVR provides? Is 8 bits enough to really get the...
It was funny when I first got the Arduino. I was researching and I was like, is this thing got enough processing power? Can it do this processing and balance me okay? And no one knew, and so it was $20, right, for an Arduino, so I got it. And yeah, it's plenty. It works. So it seems to me plenty. If there's one that would it be better if I had a faster processor? I don't know. I think it seems fast enough, but honestly, I don't know if a better processor would make it any better. Does anybody have any other?
Has a Segway lithium battery ever caught on fire?
I don't know if they have or not. I mean, if a Boeing caught on fire, a Segway I assume has. This one's got lithium ion, and I had it from a drill battery, and I took all its safety stuff out, so that thing could go. Yeah, I've shorted it before, and it hasn't gone. But if you do short them, you take them outside. I put them in a metal bucket and leave them for a couple hours. Yep.
So are you going to demo the unicycle, or?
I could demo the
Demo! And honestly, you might want to step back. One thing this does.
Something grab that cup right there.
Run out of the way.
I'm not going to be a stationary target.
One thing it's doing when I plug it in, the gyroscope will level itself, so the gyroscope takes 25 readings while it's sitting still, so it knows what it's like to be still. That's its home setting.
Does it need to be a level while you're the initial reading?
It just has to not be moving, and then it knows that it's not. So now all it cares about is oops. Now it knows it's tipping back and forth. If it just has to be sitting still at first. This will be the time I fall in my butt. I haven't yet, knock on wood. So I turn all my PID controls down. So, can you hear that? Yes. That's the PWM sound. And see, this is kind of mellow, but if I keep turning it up, that's what I was talking about. So, there's a little bit of P. It's just still vibrating, and if I take my weight off it, you gotta really, it gets a little unwieldy. Crank up that I, makes it solid. A little bit of D. Still a little, okay. That's not my best ever example.
But hey, you didn't fall on your butt though, right?
No, I know, I could have. And that's how, and I do have most of this on a website. It's called Glenn's Electric, .blogspot.com. And if anybody ever wanted to build one, I got the code for this two-wheel one on there, and I got the code for this, and pretty decent instructions and the wiring and everything. And again, buying everything off Craigslist, just cheap stuff. Get a few electric scooters, maybe an electric wheelchair. You always find them on Craigslist, and they're cheap. I don't know where the people get them, but that's where I got mine. So that's about the long and the short of it. Did anybody else have any other questions? No? Okay. Thanks a lot.
Ladies and gentlemen, Mr. Glenn Phillips with his amazing self-balancing robots. Oh yeah!